Sam, very good to see you again.
Good afternoon, sir. Nice to see you.
So, hello, I'm retired Brigadier in Cameron-Mowat. While I was still in uniform, I was responsible for the electronic countermeasures programs to protect against attack by IEDs. And latterly, I was also responsible for the active protection systems for armoured platforms. So two key areas where survivability was critical to success on operations and where the sort of information that would be displayed to vehicle crews was of paramount safety importance. Since then, I've chaired a load of conferences on every aspect of armoured vehicle technology. Over to you, Sam.
Thanks, sir. So I'm Sam Wills. I'm VP of Sales and Marketing at KME. And at KME, I've been involved in numerous programs, and from a kind of project management standpoint, from one level to to promoting technology and to taking that forward to the end user, to allow the end user to kind of work out, well, what's the best thing for my armoured vehicle platform, helicopter, submarine, whichever the thing is. So I sit in numerous kind of spaces where I wear numerous hats. Everything from this is the greatest new thing to then educating the customer to showing them what they might ask for. And we've met numerous times before.
Yeah, absolutely. And as I said, at all these different conferences, I've been chairing national, international meetings on armoured vehicle survivability, on situational awareness, on firepower and weapon systems, on power systems for armoured vehicles, protection against attack by UAVs. And in all of these areas, there has been a common factor of the importance and the safety criticality of the information presented in a coherent and understandable manner and reliably to the occupants of these fighting systems. And I think that's where KME has a crucial role to play in ensuring the survivability of the platforms and their crews. Right, and you mentioned that we'd come across each other at various different conferences. Armoured vehicle situational awareness, firepower, power systems, a whole range of different conferences to do with armoured fighting vehicles. And at many of those conferences, that range of conferences, we've come across each other, because you're quite right. Where does the business of a display SME come in? Well, it's not just one of those aspects of fightability in an armoured platform. It ties into all of them, because unless you can safely and reliably see the information that you need to see at the right time, you can't fight the platform.
You're absolutely right. And what we've come across in this is that every display that we provide into an armoured vehicle platform has a myriad of different functions. However, when we start to look at the safety side of it and the vehicle surviving, we have to work it out on the basis of each different application, or the marriage between the display and the device that it's attached to. And so along this path, what we've found is that if you had an active protection system, or you had a driving camera, or you had a weapons platform, a remote weapons station, every single one of these different pieces of equipment and assets on your platform needs to be able to have a marriage of a safety case, so that the failure modes only fail safe, and that the operator knows if they are going to fail, he has a pre-warning that that's going to happen through diagnostics. And so on the basis of that, what we are now doing, and we're doing this on a number of different platforms, whether it's under the water on a submarine program that we're delivering into, or whether it's in UK or abroad armoured vehicles, is that we're approaching it with a safety integrity level 1, 2 or 3, depending upon what the customer needs, but we design the display for the platform, for the sensor, and for the safety case of the entire platform. And so what this means then is that right at the very beginning of the process, the vehicle owner, along with the MOD, then works out, okay, what is the safety and hazards, the safety issues and the hazards for this platform, and at the outset, they appropriate what the intolerable failures might be. And so, as a company that is as I mentioned, a very long-standing display company, we've geared ourselves up very, very unusually. So we don't make displays that we sell off the shelf. We just, we don't do that. It's quite unusual. Pretty much every display we end up delivering into a platform has either been modified to meet that platform's need or has been designed specifically for that platform. And we do that very, very on purpose, because even though we see GVA and so on, and we do that, we do now find that the vehicle and that system needs to be designed from the ground up.
Interesting you say that. I'm also intrigued by the fact that you're quite clear that you don't provide a system off the shelf. How do you meet the demands of the timing of a program in order to produce something which is effectively purpose designed without making a whole program drag? How do you manage to meet the tempo of the program?
Yeah, absolutely. So KME is designed to do rapid development. So we are very design heavy. So and because we're taking previously proven electronics that in a lot of cases, we've already built and proven, and we know certain things will work. That's one instance that is a good starting point. Another good starting point is that, we've done this so many times before. So as we go through, an SRR with the customer, so we'll do that review with them, a PDR and a CDR, that is soldiering it forward at quite a rate comparative to companies that aren't necessarily geared up in that fashion. And so it is because we've got the level of engineers that are working on that specific program to do that quickly. And to give you an example, 3 months is start to finish quite often for us.
Okay.
And a program often goes on much longer than that.
Absolutely.
So that is the sort of time.
You've talked about a consistent approach in terms of a GVA or whatever. I think I feel this most personally at the moment because I took delivery of a new car last week, and I'm damned if I can work out how to control it. So I do understand the benefits of having a common approach. But I mentioned my car, this hybrid automatic thing. It's taken me a week to work out how to change the channel on the radio. But we're very familiar with the fact that our own cars now are a collection of sensors, systems, computers, communications, bluntly with 4 wheels attached and another one in front of the driver. As you look at armoured vehicles now, with all the systems that they have to bring to the battlefield, how does that affect the criticality of the displays that are presenting all that information to the crew?
You're absolutely right. So the first thing to recognise, and I think our customer, in the MOD recognises this, that the value of a platform now is much greater than it ever used to be. So it's no longer just a tactical taxi or a main battle tank with a direct fire weapon system. It's grown very much out of that, and I think where you look at the criticality of the safety or the functionality of a display, it really has grown its value on the platform. So the value of the platform's grown, and then the display itself, what it's actually doing with the user, and what the user's needing it to be successfully delivering them, has grown in not in an insignificant way. And so where you've gone from full circle from an armoured vehicle, literally let's say a main battle tank, being able to engage at a certain distance. And I remember the big arguments about the new Challenger 3's main weapon system. Well, actually, you could argue that the main capability that provides is handoff to other assets, communications. It's providing a whole host of other different things, and so I think that's probably the main go-to is why now having safe, highly reliable display technology where you as the user can be highly assured that what you're seeing is what's actually happening with a device that isn't just going to fail is absolutely integral.
So, Sam, we brought up the subject of GVA. Clearly, that's a whole international approach. But what do you see as the benefits and potential disadvantages of that sort of GVA approach?
Okay, so yeah, absolutely. I mean, firstly, GVA is something that we are very much, an advocate of within KME, and we've done, numerous versions for both NATO GVA and UK, generic vehicle architecture, both fully compliant and somewhere in the middle that smells very close to being compliant, depending upon what the user needs. And so, the positives are that they're common. They're common open architecture. In terms of their ability for the end user to, to upgrade those systems, and that's the intent behind it. The intent behind it is that you can upgrade a sensor from, you can essentially take it from another platform if you wanted, but you can upgrade the sensor. You've not got lock into a system, so it's open. It's got a very, very intelligent way of working with the 00082 decoding of what it does. We probably shouldn't go into that in too much detail. Now, but from a human factor standpoint, obviously there's a huge training benefit. So the commonality of that human factors piece, the way the buttons are and what it's doing, is that the theory is that a commander of a particular vehicle can go into another vehicle and use that exact same thing without a huge training burden.
But Sam, what about the disadvantages?
Okay, so I mean, the first thing is the starting point of what needs to be GVA. And what I mean by that is that, in some cases, this is from a human factor standpoint, in some cases, the form factor obviously really doesn't need to be GVA. From the perspective of it won't fit in the platform, it won't fit in the space.
Right.
It's a real estate issue. And then the second reason is, does the end user need a whole bunch of buttons if, it's a reversing camera display or something like that? So the truth is, no, they don't. The device can still be 00082, compliant, i.e. that's what it's receiving, or that's one of the signals it's receiving. So it can still do that, but does it really need to be GVA? Now, one of my views is that there is a possibility that we're strangling innovation by saying, okay, from a hardware standpoint, not from a communication standpoint, from a hardware standpoint, what does the future of displays hold? And there's a whole load of things coming, with the future of LCDs, how that's going to exist, the shape, the ability to mold around, the cockpit. For example. So
this is where this whole buzzword of transparent armor and so on comes in.
Yes, I mean that's actually slightly on that. That's definitely on that vein. So in terms of innovation, mandating from a human factor standpoint isn't ideal. Now, how that's been explained to me, by the GVA office is this is a guide, not a it's not law. So they can make these changes. So the innovation piece and what the future holds, is to be seen. But my feeling is that GVA, from that perspective, it can go in a lot of places. Now we've seen the sizes of displays already changing. So we've seen large format 4K displays coming from our facility. So we've been doing bigger displays.
Yep.
The other thing with GVA then is the safety piece. It's often we'll do a GVA display that has 00082 coming in, but we'll have a separate feed for that safety critical piece, which we'll get into separately. The other issue is that the display needs to really be married to the sensor in a lot of cases. So if you've got a long range sensor, so a thermal, that's got, it's bringing in a certain resolution and a certain bit rate of data. So it's bringing in a certain quality of information. You really need to be able to put that information on the screen as it's natively coming in. Otherwise, you lose an awful lot of what you paid for. And I always give this example of it's a little bit like having a Formula One car, putting Nissan Micra tyres on it. Like, make sure that your tyres are fit for purpose. It's a bit like that. And so, because then what you're getting, particularly with these long range sensors, is there's a DRI performance that you want to maintain. So then if you just bought a standard GVA display off the shelf and tried to do that, it wouldn't give you the desired effect and the desired performance. And so that's my kind of view of just the human factors piece, is making sure it's fit for purpose. In terms of what GVA does electronically within the system, it makes an awful lot of sense, and we're a big advocate of it. We just want to make sure that from our side, our customer doesn't feel that they're always tied to the parameters of that specification. Obviously, they've got to get their customer buy-in, but it's always worth to explore what's better for that platform.
Okay, thank you. So Sam, I understand that, but all electronics will fail at some stage. What are you and the customer at the MOD doing to address these issues in a systematic way?
So it's a very good question, and you're quite right to mention the MOD, because this starts with the MOD, and it's quite unusual, but they've drawn themselves to a standard called IEC 61508. And IEC 61508 is not a DEFSTAN or a MIL standard. It's actually a standard that is a civilian standard that really finds itself being used and speaks to functional safety in the space for example, like power stations and things like that.
Right.
Where, functional safety, so system level safety, is paramount. And it draws down an approach, and that approach is broken down into SIL 1, 2, 3, 4, and so on. And the further up those values you go, from SIL 1 to 2, 3 to 4, the higher they go, the more reliable and the safer those systems then need to be. And they include things like removing intolerable risks. They include mitigating a whole bunch of risks, which we can get into. But IEC 61508 was originally published in around the sort of 2000 kind of time frame. Comes in 7 parts that break down into different subjects. So the MOD have been very intelligent with how do we achieve this, and we've been following IEC 61508 as a process, along with our customer now for a number of years, and it's proven to be quite successful indeed.
All right, Sam, you've explained that safety approach, but again, why don't you just, or anybody else, why doesn't anybody else just sell a SIL 2 assessed display that you can buy off the shelf?
Okay, yeah. So, and that's a common question, and the answer is that essentially the system safety is what we're talking about, the entire system. So the safety case and the intolerable failure modes and the risks that vehicle, let's say, has are specific to that vehicle. So we're talking about the entire system. So you can say this device is SIL 2 ready when as KME or another manufacturer. But what that then means is the user then has to see, does that fit my safety case? Because the sensor might have a different set of failure modes and a whole bunch of it. So it is vehicle specific. In some cases, it might work for more than one vehicle. It might do, but it's not about the component. It's not just about the display. or the components within that display. It's the marriage between that and the device it's attached to, then the whole overarching safety case for the platform. And it's very unusual, but there are only a handful of tier one contractors, probably in the world, that make both the display and the effector or the sensor. Do you see what I mean? Because at this point, it's very much the marriage between those things. So if somebody makes the whole suite from end to end, that then offers that to the platform provider, but it still has to be that their safety case meets the requirements that the platform owner and the end user has. Now, it might be that the let's say a tier one contractor who owns everything from the sensor and effector down the digital chain to the display could manufacture and design and manufacture that whole thing with the worst hazards in mind and the worst failure modes in mind, and present that to the market, and would stand a strong chance of that being accepted through the failure mode effects analysis work that the safety person within the customer's organisation would require to pass an accredit to SIL 2 or SIL 1 or SIL 3.
Sam, you've mentioned IC 61508, this civil standard, this process. Can you run us through how that process actually works?
Yeah, sure. So essentially, at the start of this, MOD and the vehicle platform owner,
The tier one, essentially.
would come out and they would do a review together, and they would review that platform and create essentially an analysis that would speak to at the outset what SIL levels they want to apply to either the whole platform or certain elements of the platform.
Yep.
And in doing that, they would then create a list of intolerable failure modes within the system. And I can give you examples of that, as you know, and we can work on the basis of an example of that. It's probably the best way to describe it. So let's say in this one that they'll come out in their hazard and risk analysis, identifying that, and if we set a driver display, that the driver display will not lose its direct vision at any point. So the driver will always have that, whatever happens. So that might be one of their mandates. Their other mandate might be that at all times, that data needs to be present, correct, current, and can't be at any level corrupt. So they might say something like that. These are intolerables. They would then say, and we would apply safety integrity level 2 to this system. So they would start with that overarching thing. So that then, we would then be involved at the kind of, tier 3, tier 4 kind of level, naturally, because we're providing a subsystem onto that platform. So what we would then do, of course, is we would need to review ourselves, can we provide something to meet that level of scrutiny, and to do the calculation, which I'll get into in a bit. But so we would have to have that understanding, very much at the outset. We would then create, as a subject matter expert in displays, because that's really what we need to be able to do, is we need to be able to share up the line what are the failure modes, the possible failure modes of a display. So we would go into that level in a hazard log, a risk log. We provide that kind of data up within the team. So once we're then down selected, we would be providing that and working within, in most cases, within a framework of a workshop style environment with ourselves, our customer's customer. These people would all come together to do this particular effect, or to output this particular effect. And once that bit is done, KME then creates its own hazard log. And what we would then do is we would then take that list of hazards within our design process. So as we go through our SRR or our PDR or CDR, between PDR and CDR, we then have to do the FMEA piece before we actually build the thing.
Yep.
And the failure mode effects analysis work that we do, which we'll then get into with our customer before we can leave CDR, we have to have rubber stamped that we believe that all of our component level reliability creates the correct scoring to do the calculation, which I'll explain because it gets quite complicated as we go down the line. So it's about then at that stage between an awful lot of communication internally as a team to make sure that we've understood all the failure modes that we are not allowed, that aren't allowed within the system, or what we're doing about the about mitigating those. So to give you an example, mitigations might be things like redundancy. So if component reliability isn't going to be high enough, we might then need to use redundancy within the design. We might need to design the system so we're designing out failure modes. So we're keeping it simple, in the design to remove failure modes. Now, and to give you an example of that, so if we base this whole example on a driver display, as we were saying, and there is a lot of within industry, when somebody makes a display for tactical use, they would try and give that display as many features as they can, and they do that because it then appeals to as many customers as it can.
Yeah.
But in doing that, you actually quite often introduce a host of failure modes that you don't want, that then become intolerable and not reliable enough to be able to meet the scoring of what we do later. So the keeping it simple is one way to meet the criteria, to then cancel out the possibility of failure modes. So FPGAs are often used as opposed to processors. There's a whole process to how do we make a system with the highest success rate here, with the least amount of failures, and fundamentally is going to have that longevity. So one of the main things is that when we make this assessment, we're looking to reduce any single points of failure.
Right. It's very interesting that you bring the keep it simple approach into the discussion. And you also talk about not trying to put too much functionality in there because it can complicate things further down the line. Quite how that fits with the whole GVA piece, I'm not quite sure. You, in many respects, you are trying to put a quart into a pint pot in order to gain other benefits. But we've had that discussion. I think what I should do at this stage is just observe that what we're talking about here is a bounded aspect of safety. Safety, of course, goes much further, and there are many aspects of safety for which you or a tier one provider of a vehicle system are not responsible for. I very much remember from my own work as a team leader in defence procurement that many of the safety risks lay on my shoulders as the team leader who was procuring the system, or on the shoulders of an operational commander in an operational theatre, because there are many other things apart from the equipment line of development that affect overall system safety. And they're not actually the concern of a subsystem provider. They're down to the MOD.
Quite right. And so the next part of the process then, which is kind of critical, is the failure mode effects analysis. And it very much does what it sounds like. We are doing an analysis on the failure modes and what those effects are. And what we're creating now is a metric for pass or fail, essentially. And what we're doing is there is a calculation of the probability of failure. So there is, and I won't go into the real detail because it's a significant piece of work here, but that's the point, is probability of failure. versus a risk reduction rate. So we are doing some maths to calculate between the probability of failure versus high reliability. And so there is a combination of data used between, MTBF and a whole bunch of things that are brought together in that allow us to make a calculation that adds to a safe failure fraction, which then allows us to do the bigger maths piece. And what that document shows us then afterwards is that all your failure modes that are deemed to be dangerous failures and failing safe, have been shown, illustrated, and dealt with alarp statements showing as low as reasonably possible. So have we done everything to mitigate all of those safe failures in that document, which then we pass forward? And just to explain, what we're calling a dangerous, failure or detected failure, dangerous failure, safe failure, how does something fail safe? So within the design, what we will have done, a little bit like the car that you mentioned when we were earlier talking, where it gives you it tells you things. So if there is diagnostics that have been put in, which is quite possible to do, to say that this device is going to fail, slow down your driving, for example, something is something is not going well. There are things that can be put in place in diagnostics to give the operator information to mitigate risk. So it's what else is being done to mitigate the risk within that. Non-detected failures are dangerous for us because they can come all of a sudden. Typically, they don't live in this document as a success.
I think it's worth just pausing for a second. One aspect of this process that you haven't touched on so far, I take what you say on the mathematical calculations and so on. As a non-engineer, I gave up sums once letters became involved instead of numbers. But through that mathematical process, you're producing statements as to how you are meeting the different specified risks and getting to the appropriate levels of assurance. But that's the point, the assurance. How are you giving the customer the assurance that the work that you're doing in this technical process is valid, reasonable, and certified?
Yeah, it's a very good question. We don't mark our own homework. We will then pass that up the line. And generally speaking, in the teams that we're working with our customer would pass that up the line to a certified, separate body that would accredit and pass or fail, essentially.
Okay.
So, we don't mark our own homework. It's not that we couldn't, because in effect we could self-accredit to say, okay, we now meet that criteria. But ultimately, all the work that we're doing, and we do within a team. So, we have a couple of great customers we're working with actually at the moment in exactly this way, to present that data. So we would then provide not only interactions into this calculation, we then provide all the supporting information with it, which helps then for the safety case to be reviewed and agreed or not. And so that's very much what we do in this is we don't mark our own homework.
Okay. Sam, you've talked about this process in some detail, and you've emphasized beforehand that you're coming up with a customized approach to each program rather than offering anything off the shelf straight away. But what about the time and cost implications of this?
Okay, so invariably, there is a time and a cost consideration. However, this activity runs as parallel, in tandem with the design process. So the team, yes, they have more to do, in terms of providing, the information and the design and all of that good stuff. So there is a a small cost in there, that because obviously that has a cost implication. However, the value that this activity then provides back from an assurance standpoint, but from a reliability standpoint, should pay back the customer significantly. So if you were to take an off the shelf, from a different provider, and you were to say, right, okay, well, I'm going to put that on the platform, and you saved yourself some money, it's a short-term saving, and so the timings for us with this kind of activity, it is in tandem, as I say, and you're looking at our design times are very quick, and so we're looking at the quickest we've done it is 3-month turnaround.
Okay.
Which is, that's not it being accredited. That's providing the FMEA, the full design, and a certified display solution for an armoured platform. But that's from the very beginning of the design of a brand new display, for an armoured platform. So if you think 3 months with the FMEA work and all of the other pieces considered, that's pretty quick. I would say that it probably averages more like 6 months from start to finish, because there's a lot of external factors, qualification, the external body who would accredit it.
Yeah.
All of those things are external factors.
You make a good argument there, but who are you making this argument to? Are you making it to the customer, or are you making it to the prime that you're working through?
I would say it's really to the prime. The customer, understands this, and MOD, is mandating this specific, requirement, IEC 61508, SIL 1 or SIL 2,
Yep.
in platforms. We're seeing that it's coming down, so that's music to our ears. The tier ones, who are the platform integrator, ideally need to get ahead of this, if they can, because they can then start to think about, what are we offering on this platform to make this a smooth process? Are we saying that this is already, driver safe, weapon system safe? How are they approaching that? And I fear that a lot of primes would have already got their preconceived ideas of what they're offering, and perhaps they need to have a rethink.
Okay. Sam, that's great and very clear. Thank you. Can we just zoom out a little bit? I'd like to ask, what else is KME up to? What's in the future for the company?
Great question. So we've got a lot happening. So where we currently stand right now in terms of products that we are promoting, our UK sales manager is very, very mobile around showing the MVIS solutions that we're delivering in. So we're looking at light mobility programs and so on. And that's very much about signature reduction. So again, this is us presenting something into this space that does signature reduction, which ultimately, like what we spoke about earlier, that there's a significant element to that does operational success and operational safety. So we have those kind of things going on. We have numerous partnerships in relation to that, which are very exciting. Also, KME, although we are very known as a display company, we have a myriad now of innovations which are being brought forward and we're working on. So, displays are our bread and butter. We're consistently going to continue to put effort into that, and it's not going to lose focus. That's the hedgehog. So, and the hare that we're really punching forward with is really in the soldier systems. So we brought RAW to bear, and we're starting to show what some of that does.
Sorry, RAW?
RAW, yeah, which is remote operated IR, so infrared. So we're doing a bunch of things in the night vision space in terms of marking locations, people, and that's all being done remotely. It's a really unusual and interesting innovation, which takes away from chem lights, glow sticks, essentially being cracked and flown on the floor, because both sides have night vision now. So this is more about being able to identify somewhere and turn it off again. And there's a whole host of different things that you can do with that. Now that it's got a family of products related to it. So we've only shown the glow sticks, but we've got some really exciting stuff. And one of the things that follows RAW will be in relation to the denial of opposing forces night vision goggles. So we've got some really interesting stuff that we're bringing forward in that space. And then outside of the RAW family, we've got some weapon laser technology that we're bringing forward, that we're working heavily on to revolutionise how weapon systems are employed and how we utilise IR lasers. So again, look forward to that. There'll be more information on that as we come out. We've sanitised some of this with everyone from certain specialist units down to regular units who are all keen and interested, including weapons manufacturers that we're looking to partner with. So there's a number of different scales in which and directions in which we're going with that. Very interesting to the special forces market. Very interested in taking it forward into the United States, taking it into their special forces. There's a whole host of where we're headed with that. Also, outside of the weapon system advancements that we're bringing forward for the soldier, we've also started a new company. KME's had about a year ago started a company called Simiot, and Simiot is relating to the sort of quantum computing space. And so again, now we're in cyber, and cyber is a big thing right now, and everyone's looking. And as you know, with conversations about drones and how all of these assets play on the battlefield, one of the things that we're bringing to bear in that is the handshake between those devices or those assets. And we've gone through the process. We have our patent approved for our novel sequence of hardware that we're bringing forward, and we're in conversations with DASA and those kind of guys to bring that forward into the UK. But essentially, and we were having conversations about your AirPods and your phone and pairing. Well, it's like that, but how do we ensure that your phone knows that your AirPods are your AirPods, and so on and so forth? And we've talked about how jamming or how spoofing and how just mission critical it is to guarantee that this thing is what it says it is, and this thing is what it says it is, and nothing in between can get in the way. And that's something that we've been working very heavily on. So those things are taking place. Very interesting, exciting times for KME, and watch this space, and I'm sure we'll bring more of that to your front door.
Fascinating. A clear message at the end of that is it's not just tablets and displays. All of the other aspects you're talking about there are very interesting. And in that short pitch, you managed to come up with cyber, drones, and even lasers. Hot topics, and KME is clearly pushing ahead beyond the area for which it's well known. But those new areas are very interesting. Of course, you said quantum as well, so that's another tick. Those areas are very interesting indeed. But I was pleased to hear that what you said was that the displays business and the engineering rigor and the processes that go in there still form the bedrock of what you're doing, and all of the work you're doing, taking proper account of safety, is a key factor in building towards mission success. And in the end, that's what it's all about. Thank you.
Thank you.